Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing awesome. Let's go ahead and start with a word of prayer. Dear Heavenly Father, I want to thank you for this day, goodness, Lord. I want to thank you for all you've done. I pray that you'll bless my students with knowledge and understanding and just help us all have a good day. We love you, Lord. In Jesus' name, pray, amen. Hi guys, so today we're going to be learning how to use congruent triangles. This is lesson 4.6, page 256. So let's go ahead and get started. By definition, congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent, you know that their corresponding parts must be congruent as well. So guess what? We're going to write a proof. Use the given information to prove the parts of the kite are congruent. So we're given that GK bisects FGH and angle FKH. So if GK bisects these two angles, what do we know that causes? What do we know the outcome of a bisector is? We know that it splits those two angles perfectly in half. So we can say that angle FGK is congruent to angle HGK and FKG is congruent to HKG. And we know that by the definition of bisectors. Okay, so let's go ahead and mark the information we just wrote down. We know that this angle is congruent to this angle, and this angle is congruent to this angle. Okay, so now of the two triangles, we know those two angles are congruent. Ultimately, we're trying to prove that FK is congruent to HK, and guess what? We just learned on the last slide, if you could prove the two triangles are congruent, you could prove all their parts are congruent. So to prove FK is congruent to HK, we're actually going to have to prove the two triangles are congruent. And we're actually only like one step away from being able to prove the two triangles are congruent because the two triangles share a common side, which is GK or KG. And we know that GK is congruent to GK by the reflexive property of congruent segments. Man, I seem to be stuttering on congruence tonight. Sorry about that. Let's just keep going. So now we know that these two triangles are congruent, and we know that they're congruent by the ASA congruence postulate because we have an angle, a side, and an angle to prove that they are congruent. So let's go ahead and say that the two triangles are congruent. Triangle FGK is congruent to HGK by the ASA congruence postulate. Now, we know they're congruent, so we're able to just say that FK is congruent to HK since corresponding parts of congruent triangles are congruent. This is a lot of words to write down, so in the future, you can just write bang, 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 CPCTC, okay? Congruent parts of congruent triangles are congruent. This is a huge shortcut because now we could have just said, so FK is congruent to HK by CPCTC. Okay? I hope that made sense. Let's go ahead on to the next example. If P is the midpoint of MS, how wide is the cow's pasture? So we know that P right here is the midpoint of MS. So that means that MP and PS are congruent. They're both actually 30 feet. It's marked there too. We know that they're 30 feet. And we're trying to see how wide the pasture is right here. Well, we know this length is 40 feet. So if we could prove that RS is congruent to RN, we're able to say that the pastures are 40 feet wide. But we can't just assume that it's going to be 40 feet wide. So we know that MP and PS equal 30 feet, so they're congruent, okay? We also know that this is a right angle and this is a right angle, so that makes those two angles congruent. Lastly, if we look here, we have a pair of vertical angles, so we can actually say that angle MPN and angle SPR are also, I'm going to do double arches since there's a right angle, are also congruent. So by CPCTC, we can say that RS is congruent to MN, making the pasture 40 feet wide. Okay? Easy as that, guys. Today's a pretty short lesson. We only actually have one more example to go, so let's just keep going and get done for the day. Example 3, they want us to write a plan for a proof. Given that angle 1 is congruent to angle 2 and 3 is congruent to angle 4, they want us to prove that triangle MNR is congruent to triangle QPR. Okay? So we want to prove MNR, this little triangle right here, is congruent to QPR, this little triangle right here. And this one is going to be a shocker for you. Number one, we're writing a proof, so you don't have to state your givens or any of that stuff, but we know that angle 1 is congruent to angle 2. These two angles are congruent, so I'm going to mark that. 1 is congruent to angle 2, and 3 is congruent to 4. Okay. Because we know 3 is congruent to 4, we also know 5 is going to be congruent to 6 because 3 and 5 are a linear pair. 4 and 6 are a linear pair. So by the congruent supplements theorem, we can say that 5 is congruent to 6. So let's go ahead and say that. 5 is congruent to 6. That's 3 arches. Man, I'm really drawing this picture up. Okay. Now, real quick, ultimately, they want us to prove this triangle is congruent to this triangle, but to do that, we really have to go a roundabout way. We're actually going to try and prove that MN is congruent to PQ, because I'll show you why that's important, but we're really going clear around the lake on this one, you guys. We're going for a hike. Let's go ahead. I'm going to draw 2 different triangles besides the 2 we're trying to solve. I'm going to draw this purple triangle, MPQ, and I'm going to draw this blue triangle, QNM. Okay? If we look at those 2 triangles, we know that they have 2 angles in common here and 2 angles in common here. And they actually share a common side, MQ. And MQ would be congruent to MQ by the reflexive property of congruence. So we're going to go ahead and write that down. So we can actually say now, because we have side, angle, angle, or angle, angle, side, that those 2 triangles are congruent. So let's go ahead and say that triangle MNQ is congruent to triangle QPN. And by doing that, now I'm going to erase those 2 triangles so they're out of our way. We can actually say that MN is congruent to PQ because of CPCTC. Okay? So let's go ahead and say that MN is congruent to PQ. So this side is congruent to this side. And we're trying to prove that this little triangle, here I'll draw it purple and blue. We're trying to prove that the purple and the blue triangle are congruent. Well, we have a side and we have an angle. And we're actually able to prove one more set of angles right here because they're vertical angles. So we can say that angle NRM is congruent to angle PRQ by the vertical angles theorem. Okay, now that we proved those 2 angles congruent, which this is so sloppy, I'm just gonna put little red dots there showing those are congruent. Sorry, that's not appropriate, but we actually have an angle, angle, side again. So we can say that those 2 triangles are congruent by the angle, angle, side congruence theorem. Wow, that got really sloppy on me really fast. I apologize for that. But watch it a couple times. I'm sure you could work through my sloppiness. I hope everybody's doing good. I'm really enjoying this, so just keep following along. Keep learning, keep being awesome, and you know what? I hope you guys have a great day. See ya!